Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at the graph of the cosine function. Prior to this video, I did do a three-part series on the graph of the sine function, and I strongly encourage you to take a look at that before we take a look at the cosine function, because I'm going to be going faster with the cosine function, assuming that you already understand the concepts I talked about in the series before this. So let's take a look at the graph of y equals a times cos of bx plus c. Each of these letters will be a transformation on our basic graph of y equals cos x. So let's take a look at what y equals cos x looks like first. If I look at my 5 key x values, starting at 0, pi over 2, pi, 3 pi over 2, and 2 pi, I get the following values. The cos of 0 is 1, cos of pi over 2 is 0, cos of pi is negative 1, cos of 3 pi over 2 is 0, cos of 2 pi, which is the same as 0, is 1, and then we repeat those values. Again, our x-axis has to be our angles expressed in radians. It doesn't work if we do degrees. And these are the same values of x that we had for sine function, but because it's cosine functions, our y values will be different. So what our graph is going to look like if we were to plot these 5 points at x equals 0, y equals 1. At x equals pi over 2, y equals 0. At x equals pi, y equals negative 1. At x equals 3 pi over 2, y is 0. And at x equals 2 pi, y is equal to 1. So if I were to connect these in a smooth curve, my cos function without any transformations would look like this. And again, remember that this would continue to the right and to the left. So it really is identical to the sine curve, except it shifted over. If we were to move this over, it would look exactly like the sine function. You want to get familiar with this shape for one cycle of your cosine function. When we talked about the sine graph, we talked about amplitude, which represents the highest y value that the graph will reach. It's still defined as absolute value of a. The period of the function, cosine is also a periodic function, which means that its shape repeats and repeats. It just continues on. It's defined as 2 pi divided by b. I showed you a method where I used increments to find my 5 key values. I'm going to do that with cosine function as well. It's defined as the period obtained here divided by 4. Because there's 5 key points, there's 4 intervals. And displacement, where it shifts left to right, will still be defined as negative c divided by b. So what I want to start with is graphs of cos of x where we have a value of a not equal to 1. We learned in the sine function videos that if a is greater than 1, your graph will be stretched vertically. If it's less than 1 but greater than 0, it will be shrunk vertically. And if it's negative, it will flip over the x-axis. Same thing true for the cos function, and I'll just illustrate that with some examples. If we were to draw y equals 2 times the cos of x, it's going to be, we're going to use the same 5 key x values, and our y values will all be double what they were with our basic function. So our amplitude is 2 instead of 1, but our x values are the same, 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when x is 0, cos of 0 is 1, 2 times 1 is 2. At x equals pi over 2, cos of pi over 2 is 0. 2 times 0 is 0. Cos of pi is negative 1, times it by 2, we get negative 2. Cos of 3 pi over 2 is 0. Cos of 2 pi is 1, so we double it by multiplying by 2. So our graph will look like that. Very similar, we've just stretched it vertically. Similarly, if we had a equal to 1/4, all my y values will be multiplied by 1/4, so it shrinks it vertically. So I still work with the same key points. But now, my y values are 1/4 of what they were in the original function. So you can see that we squished it vertically. When we have an a value that's negative, remember it flips it over the x-axis. Same key values for x. But if I take all the x values and multiply them by -1, I'm going to start, my graph will basically be flipped from what it was. Cos of 0 is 1, times it by -1 is -1. Cos of pi over 2 is 0, doesn't matter if you multiply it by a negative value. Cos of pi is -1, multiplied by -1 will be +1, 0 here. 1 times -1 gives me -1. So the graph is going to look like that. So it just flipped it over the x-axis. And just as a reminder, the amplitude of each of these curves is determined by the value of a. So it's the absolute value of a. So in this case, the amplitude is 2. In this case, the amplitude is 1/4. It's the highest y value the graph will reach. And in our last example, amplitude is the absolute value of -1, so the amplitude is 1. The period for each of these, how long does it take for the graph to complete one cycle before it starts repeating itself? It's 2 pi divided by 1 because my b in each of these is 1. So the period of each of them is 2 pi units. Let's now take a look at examples where we have a coefficient in front of the x. So in other words, b is not equal to 1, and see how that transforms the graph. So in our first example, we have y equals cos of 4x. So I won't worry about a being anything other than 1 in my first example. Let's start by finding these characteristics, and that's going to help us draw a very good representation of this function. So my amplitude is equal to the absolute value of a, which is 1. The period is 2 pi divided by b, and in this example, b is 4, so the period will be pi over 2. And then I also like to know the increments for the particular graph, because that tells me, once I know my starting point, I know where my key points, how far they are from the starting point, and then each point as I go. So the increments will be the period divided by 4, so pi over 2 divided by 4 will equal pi over 8. With that information, and knowing what my cosine curve looks like, I can draw a fairly good representation. So I always start at my starting point. In this case, it's the origin. I haven't shifted it left or right. And the amplitude is 1. So those are my maximum and minimum y values. And then I have increments of pi over 8. So when I start at 0 and I increase by pi over 8, it will be pi over 8. Then another pi over 8 will be 2 pi over 8, which I can reduce to pi over 4. Another pi over 8, add to this, gives me 3 pi over 8. And I add pi over 8 to this, that will be 4 pi over 8, which is pi over 2. You can always check, is this interval equivalent to the period of pi over 2? Yes, it is. That's how long it takes the cos curve to complete itself before it starts over. If you've done it correctly, this distance should be what you've calculated for the period. So our cos curve starts at 1, 0 here, -1 here, 0, and +1. Now I haven't drawn it to scale compared to what the cos curve normally looks like, but because this number was greater than 1, it actually shrunk it horizontally. So I would be able to complete 4 cycles of that curve in the same distance as it took 1 cycle without that coefficient of 4. Let's try some more examples. In our next example, a is equal to 1/3, and you might find it useful to write these things down, especially when you're filling those values out. B is 1/2. So the amplitude is the absolute value of 1/3. The period is 2 pi divided by b, which is 1/2. When I divide by 1/2, it's like multiplying by 2, so this will be 4 pi. And the increments will be the period divided by 4, so pi units along our x-axis. Given that information, I can draw the graph. So my starting point is the origin. There was no horizontal shift. There was nothing added or subtracted inside the cos function. And my amplitude is 1/3, so my maximum value is 1/3, my minimum value is -1/3. So I start at the origin where x is 0, and I go by increments of pi. So pi, another increment of pi is 2 pi, another increment of pi is 3 pi, and another increment of pi, I add pi again, is 4 pi. So the graph starts with cos of 0 being 1, and then I multiply it by 1/3. Cos of pi times 1/2, and so on. I can actually calculate these points, but I know that my next point will have a y value of 0. At 2 pi, my y value will be -1/3. At 3 pi, my y value will be 0 again, and at 4 pi, it will be 1/3. So my graph is going to look like that. Period is 4 pi, yes it is. The increments are pi, yes they are. It's the cos shape. I started at x equals 0. And 2 things happened. The 1/3 squished it vertically, and the 1/2 inside the cos function stretched it horizontally. So hopefully you're comfortable with what A does to the curve and what B does to the curve. I want to now look at what C does, what the transformation of a C value other than 0 does, and I will do that on the next video. So practice with just changes of A and B. Make sure you've got those down, and then when you're ready, check out the next video.